Okay, this is a video for number 9 on the final review 2, one of the packets on the Canvas page. All right, so let's start by, we want to find, one thing I should say is it is told that k is an integer, so it's contained in the set of integers, and k is greater than 2, and we're solving for k. Okay, so to do this, the first thing I notice is that on the left, I've got addition of logs of the same base, and let's make 2 log base 10 of 100. So then I can condense separate logs separated by addition into a single log by multiplication. So this would be log base 10 of k minus 2 factorial, k minus 1 factorial, and then times 100. And on the right side, again, because it's the same base, let's bring the 2 up to the exponent. Because remember, the nice thing about if you have a log of the same base on both sides, then the only way this is true is if the insides are equal. So I would say 100 k minus 2 times k minus 2 factorial times k minus 1 factorial equals k factorial times k factorial. That was k factorial squared. And I think the way to think about simplifying this is kind of write out a little bit what factorial means. So again, we just have this kind of 100 hanging out. And then let's see what k minus factorial means. You keep on subtracting. So if it's 10 factorial, it's 10 factorial times, it's 10 times 9 times 8. So you keep subtracting 1. So k minus 2 factorial would be k minus 2, k minus 3, k minus 4, and so on. And that gets multiplied by k minus 1 factorial, which is k minus 1, k minus 2, k minus 3, k minus 4, and so on. And that's going to equal on the right side, k factorial would be k minus 1, k minus 2, k minus 3, and so on. And the same times itself. So k minus 1, k minus 2, k minus 3, and so on. And the purpose of me doing this is to see, okay, what is really going away here? So on the right side, let's see if I can show you. This k minus 2, k minus 3, and so on, that can cancel with this k minus 2, k minus 3, k minus 4, and so on. So that can go away. And also on this right side, let's see what we have. We have k, the k and, the k minus 1 does not stay, right? So that can cancel. So k minus 1 on can cancel on that side. Interesting. Okay, so what we're left with is 100 equals k squared times k minus 1. So honestly, at this point, I would then do a little bit of guess and checking. So I know that k is an integer, and I know that k is greater than 2. So let's just test 3. So if I plug in 3, I'd get 9 times 3 minus 1 is 2. Way too small. So it's not going to be k, it's not going to be 3. Let's test something like if k were 6. If k were 6, I'd get 36 times 5, which is bigger than 100. So that's a no-go. So it's somewhere then between 3 and 6. Let's test 5. If k is 5, we get 25 times 4, which indeed is 100. So there we go. Boom. It's k equals 5.